So now we are having next assignment on random forest, where you are going to see how to implement the bootstrapping. And for that, here you have to implement the three tasks, task 1, task 2 and task 3. So let's try to understand the instructions for all these three tasks one by one. But before that, as a foremost step, we are going to import some of the libraries here. And also in this assignment, we are going to use the Boston House dataset that we are directly importing here from scikit-learn datasets. And now you can load your dataset, and we are storing your data and the target into variable x and y. So after that, now you can check out the shape of your dataset using x.shape, that we are having 506 rows, or you can say we are having 506 data points, and we are having 13 features or 13 columns in your dataset. Fine. So now let's quickly move on to the task 1 here. So for the task 1 here, you need to perform 3 steps, step 1, step 2 and step 3. So for the first step here, you have to create the samples. That is, you have to randomly create 30 samples from the whole Boston data points. And how you are going to create each of these samples? So for that, first you have to consider 60% of 506 data points. 60% of 506 means that you have to consider any random 303 data points from the whole dataset. And after that, now you can replicate the rest of the 40%. That is, now you can replicate any 203 points from the sample points. So for better understanding, let's try to understand this thing with an example here. So let's suppose if you are having 10 data points in your dataset like this. So first what you have to do is you have to first consider the 60% of the points randomly from this dataset without any repetitions. So 60% of the points will be like this. And once your 60% are ready, now for the rest of the 40%, now you can replicate it from this 60% of sample data points like this. Okay. So now your final sample will contain the data points in the order that you can see here now. So now our final sample is of size 10, that is equal to the original dataset. That is equal to the size of your original dataset, for example 10 in our case. So just like here, now you have to create the dataset, now you have to create the samples for using 506 data points, and you have to create 30 samples like this. And also, as a part of the bagging, when you are taking the random samples, make sure that each of the sample will have different sets of columns. So for selecting the rows for your sample, we are having all of your 30 sample is going to have same size, that is equal to the original size of the dataset. But now for selecting the columns here, you can have the different sets of columns for your samples. For example, let's say if you are having 10 columns, then for the first sample, you are going to select the feature set of length 6 here. And for the second sample, you can select the feature set of length 7 and so on. That means you can have a different set of features for your 30 samples. And also one more thing that you can see, that for selecting the rows, we can have a single row can repeat more than once within a sample, because we are replicating the 40% of the point from the 60% of sample data points. So that's why we can have our data point can be repeated more than once within a sample. But now when coming to columns here, you can see that a single column will not appear more than once within a sample. And also we are going to have a different set of sample for your 30 samples. But make sure that each sample will have at least 3 features, or you can say 3 columns or 3 attributes. Fine. And now once your 30 samples are ready, so coming to the step 2 here, now you have to build the high variance model on each of these samples, and you have to find train MSE value. So for that, now you have to build a regression tree with high variance. That means now you can grow your tree as long as it can on each of your 30 samples. And after that, now you have to compute the prediction for each of your data points in your dataset. That means now you have to do the prediction for 506 data points in your corpus. And how you are going to do the prediction? So for that, let's suppose if you have to predict the house price of the ith data point in your corpus, then you have to use all your 30 models for doing the prediction for that ith data points. And in the end, now you have to do the summations for all your 30 prediction, and you have to take the average of it. Okay. And now in the fourth step here, you have to calculate the MSE, that is your mean square error, with the formula 1 by n. summation of I is equal to 1 to n, where n represent the number of data points, that is 506 in our case, yi minus yi prediction to the whole square. Got it? And now coming to the step 3, where you have to calculate the OOP score, that is out of bag score. So here the first and the third point are going to be same as your step 2, but now the second point here where you have to do the prediction, that is slightly different. So here, in order to do the prediction for your ith data point, here you have to consider only those model that was built on the samples that not included that ith data point in the samples. So coming to the step 2, here you have to consider the prediction from all the 30th model. That means you have to use the prediction using all your 30 models, and you have to take the sum of it and you have to do the average. But now while calculating the OOP score, you have to consider only those k model that was built on the samples that not included that ith data point, and you have to take the summation of those prediction and you have to take the average of it. Okay, so let me just give you a brief overview again that what we have discussed in the task 1 here, that initially we are having the 506 data points in your corpus, and as a first step you have to create the samples, and you have to create 30 such samples, and all samples are going to be of size 506. So we are having all your 30 samples are going to be same size as 506. And how you are going to create the samples? So for selecting the rows here, you have to first take the 60% of the points randomly from this original data set without any repetitions, and after that the rest of the 40% now you can replicate it from this 60% of sample data points, so that in total you are having the sample size equal to 506, that is same as your original data set. And now for selecting the columns here, you have to make sure that each of your sample is going to have a different sets of column, but also every sample is going to have at least 3 features, or you can say 3 attributes. Got it? And once your 30 features are ready, now you have to build the regression trees with the high variance. Now you have to build a regression tree model with the high variance. So for 30 samples, you are going to have the 30 regression trees. Okay? And now for calculating the mean square error, where you have to do the prediction for your ith data point in your corpus. So for that, you are going to use the prediction from all your 30 models. So let's say from the regression tree 1, you are going to have the prediction for this point, that is yi1, and just like that now you are going to have the predictions from all your 30 models. And once you got your prediction, now you have to do the summation of all of them, and you have to take the average of it, yik. So this will be your final prediction for a single ith data point in your corpus. And now for calculating the OOP score here, where for doing the prediction for your ith data point, here you don't have to consider all your 30 models. Here you have to consider only those model that was built on the sample that not included that ith data points. So let's say that yi1 is built on the sample that not included this data point, so we are using the prediction from this model. And let's say we are not including the prediction from the second regression tree, because let's say the sample here contains this data point, and so on. And just like that, we are going to use only those models for the predictions only, and we are taking the average of it. So that's the difference between how you are going to calculate your MEC and the OOP score while calculating the predictions. So now let's move on to the notebook here. So as a task 2 here, now coming to the task 2 here, you have to calculate the confidence interval of your OOP and your train MEC. And for that, now you have to repeat the task 1 for 35 times. So here, so this is the thing you have calculated for the first iteration. Now you have to repeat the same thing for 35 iterations. So for the 35 iteration, now you are going to have a different set of 30 samples for each of your iterations, and you have to build the regression models, 30 regression model with a high variance on the top of it, and you have to calculate the MEC and the OOP score for each of your iterations here. So for the 35 iteration, you are going to have your 35 MEC values, and you are going to have your 35 OOP score, and you have to store it in a list format in order to calculate your confidence interval. So for the 35 iterations, you are going to have 35 different values of MEC and your 35 values of OOP score. And now you have to consider And now you have to consider all these 35 values as a sample, and you have to find the confidence interval of MAC and the OOP score. And how you are going to calculate the confidence interval? So for that you can refer the central limit theorem notebook that we have discussed in one of our videos, and you can check out this notebook that how you are going to calculate the confidence interval when the population standard, when you don't have the knowledge about the population standard deviation. So you can take the help of this notebook in order to estimate the confidence interval for your random forest assignment with respect to your MSc and your OOP score. Okay, and now coming to the task 3 here, where you have to predict the price of the house for a given query point, or you can say the test data. So let's say you are having a query point that is XQ that contains the 13 features here, and all of them are numerical in nature. So here you have to predict the house price for this query point as mentioned in the step 2 of the task 1. So now coming to the step 2 of the task 1, that means now you have to consider all your 30 model for doing the prediction for that query point, and you have to take the summation of it, and in the end you have to do the average of it, and this single value will be considered as a prediction for your query point here. So you have to show that value to us. Okay, fine.